Good afternoon. Today we will start with unit number 2, and in that unit number 2 we will see lecture number 1. Unit number 2 is consisting of two parts. First is linearization of nonlinear functions and second is block diagram reduction. Out of that we will start with the linearization of nonlinear functions. First, you should know what is meant by linear function and what is meant by non-linear function. Suppose, for example, we will take one graph. This is one graph where here you can say x-axis, here is y-axis, here is y-axis. Then suppose here is x naught value of, with this value of x we are getting some function y on y-axis is f of x naught. Means at the value of x equal to x naught, we will get some value on y-axis which is nothing but f of x naught. Suppose the value of x naught is increased by delta x. So that new point we will get there x naught plus delta x is new value of x. At that point we will get value of y as a function of x naught plus delta x. So what we will say that it is, let's say, x1, it is, let's say, f of x1. Now I want to find out the slope of this diagram or of this function. Slope is nothing but change in output upon change in input. So here change in output you can say delta f, and change in input you can say delta x. Delta f is nothing but this is delta f. Here we have already written delta x. Delta f is equal to f of x naught plus delta x, which is final value, minus f of x naught, which is initial value, divided by delta x. Further we can write f of x1 minus f of x naught, which is divided by x1 minus x naught. So this gives the slope, and here this is linear function. As the value of x change, the value of y will also change with the same proportional. Whatever that x is having value, proportionate to that value of function f will also change. Here the slope of this line is not dependent on the choices of a point. Means if I choose this as an initial point x naught 1, and if I take this as the output of this f of x naught 1, then also we will get same slope. That is the linear function which varies linearly. If we consider a non-linear function, in non-linear function which is having curve as a graph, if I will draw the graph, its graph is looking like, for example, this. Now here we want to find out the linear approximation of this curve which is non-linear function. For that, simple procedure is what? Let's choose 2 points on this graph and draw one line passing through those 2 points. Now what will happen if suppose this is first point x naught, this is second point which is, let's say, x1, and corresponding to that here is one first point on y, which is, let's say, y1, this is, let's say, y0, and this difference is delta f, this difference is delta x. You can find the slope simple way, delta f upon delta x, which is nothing but f of x1 minus f of x0, which is nothing but y0 y1 x1 minus x0. But suppose instead of choosing these 2 points, if I found these are the 2 points, then if I draw the line passing through those 2 points, we will get 2 different points on x and y. Means here there will be x0 1, here will be x1 1. Same way you will get points on y-axis, and at that time you will get some different slope. Means the slope of the line which is passing through 2 points of a curve will have different slopes, and you will get different values of slopes. For that, what it is said that, or instead of drawing 2 points and drawing a line passing through those 2 points, choose one point of a curve and draw tangent to the curve from that point, and then find out the equation of that slope line, and that will be the approximation of the curve. So this concept will be more clear when we see one example. This example is of plotting a non-linear relationship between one small example. Let's see that example. Let's see the example, or rather say a derivation of finding non-linear relationship between y is equal to x square. For that, I will draw one graph. Understand thoroughly. Horizontal is x-axis, vertical is y-axis. I will not write. Then this is the curve which is representing the equation y is equal to x square. Means value of y will vary with the square of x. For this derivation, we will choose one point on curve, and that point is called as a xi yi, and this is also known as a xi yi is known as a reference point, that is reference point. With respect to that, we are finding out the approximation. Then I am choosing one more point on the curve which is nearer to that xi yi point, and that point is xy point. And we are interested in the finding out the value of y, what will be if the value of x changes from xi to x. Means we are interested in finding the value of y when value of x will vary from xi to x. That is nothing but linear approximation. For that, what we will do, I will just draw the positions. Here is the position of, this is yi, this is xi. Similarly, this is y and this is x. Then to do the linear approximation, what we are doing, we are drawing one line tangent to point of reference. So this is the tangent line. Now that tangent line is crossing here to the projections of xy. So I am concentrating on this new point. The dimensions of these 2 points, if we want to find out, so I will draw horizontal line and vertical line from that point. This is vertical line, and let's say this distance is small x and this distance is small y, and this small distance is, let's say, epsilon. So from this diagram, what we can write, let's see. What will be the value of y? Capital Y means this y, and we will write equation y is equal to yi plus small y plus epsilon. Means which distance? This distance, which is y plus epsilon. Now as we know that we are doing the approximation. In the approximation, what we are doing? We are neglecting this small epsilon. We are just neglecting it, so that approximation will have small error. So yi plus y if epsilon is small, too small, we will neglect it. Then from this we can write the equation of slope. Slope will be nothing but y by x, which is equal to dy by dx at I, which is nothing but slope at xi yi. Means at this point, what will be the slope? It is nothing but derivative of y with respect to x at position I. This sign is representing the derivative is to be evaluated at the reference condition, that you will understand in the problem. And dy by dx is the derivative of the reference point. So what you will get by rearrangement? We will just do some rearrangement. Y is equal to dy by dx. Remember, everything here is the capital multiplied by small x, which is equal to, we know our function is y is equal to x square. So what you will get? What you will get? Dx square upon dx multiplied by small x. So at the end, by taking the derivative, y will be equal to 2x at I multiplied by small x, which is equal to y is equal to 2xi. Value of x at position I is xi, means x at position I is nothing but xi. Value of x at position I will be xi multiplied by x. So that this is the equation. Finally, you know what we have written here. So what we know, y is equal to yi plus small y. Let's take that as a reference. What we will get? Capital Y, that is approximate y is equal to yi plus 2xi into x, and this will be our approximate equation of y. Y will have this value by considering approximation. So we will understand this with some example. For that, we will take small example. I will write that example here. So this is the example. What it is saying, the equation is given y is equal to x square, and what they have given, the initial value of x is given 10. So for the values of x in the neighborhood of 10, and find the error when using this approximation when x is 11. So xi is equal to 10 initial value and x is given 11. So what is the condition? The reference point which we are using here is the xi yi. This xi yi we have to find out. So xi is already given, which is 10. They have given. By using the relation y is equal to x square, we can find yi is equal to xi square. So yi is equal to 10 square, which is equal to 100. So we get the reference points xi yi, which is equal to 10 and 100. That is the initial condition. Then our equation of y approximate is YAP, I will write, is equal to, here we have yi plus 2xi into small x. 2xi into small x. So what is the small x? Small x, from the graph you will see x minus xi is equal to x. So what is x? What is xi here? Here x is 11, xi is 10. So what we will get? Small x is equal to x minus xi, which is equal to 11 minus 10, which is equal to 1. So that will be the value of x. So finally, by putting the all values, approximate value of y is equal to yi is 100 plus 2 multiplied by xi. The value of xy is given to us is 10 multiplied by 1. So what will be the value? 100 plus 20, which is equal to 120. So y approximate, by using the approximation equation, this approximation equation, we are getting the value of y approximate equal to 120. And if we calculate by using the actual equation y is equal to x square, what we will get? Y is equal to 11 square, which is equal to 121. This is real value of y. This is approximate value of y by using the, so by using the approximation, we are getting error which is less than 1%. So this approximation is accepted. So this is the example how we are using approximation method in the system. Why this linearization is required? The need of linearizing the nonlinear relationship is frequently encountered in control engineering. Example, most of the mechanical speed control system incorporate a flywheel governor for sensing the speed error. This is centrifugal device. So the force is obtained which is proportional to the square of a speed. So we have to approximate that nonlinear equation for linearity. Now we will see the general form of a nonlinear equations which are to be converted into linearity. For that, we will consider one function y is equal to y, a function of x1, x2, x3 up to xn, where n is independent. Then by using mathematical rule, we will have its derivative, which is nothing but variation of y, that is delta y. Variation of delta y, we can write the equation delta y is equal to dou y by dou x1 at I multiplied by delta x1 plus dou y by dou x2 at I delta x2 plus up to dou y by dou xn at I delta xn. So what it is written here, the derivative, which is nothing but partial derivative of this y with respect to first variable at position I multiplied by delta x1 plus partial derivative of y with respect to second variable at position I or at reference I multiplied by delta x2 and so on. We have to make it simplify. Here delta y is equal to y minus yi, which is equal to small y, which we have seen in our first graph here. I will show here this y, small y. Y minus yi is equal to small y. Similarly, x minus xi is small x. Same way, x1 minus x1 I is equal to small x1. Like that, x2 minus x2i is equal to small x2 up to xn. So like that we can write delta x1 is equal to x1 minus x1i is equal to small x1, delta x2 is equal to x2 minus x2i, which is equal to small x2, and it will continue for delta xn is equal to xn minus xni, which is equal to xn. By putting these values in the equation first, what we will get, delta y will be replaced by small y. So small y is equal to dou y by dou x1 at I multiplied by x1 plus dou y by dou x2 at I will be x2 plus dou y by dou xn at I is multiplied by xn. Making further simplification, what we are doing now, dou y by dou x1 at I we are writing as c1. Dou y by dou x2 at I we are writing as a c2. Similarly, dou y by dou xn at I we are writing cn. So final term which we want is the small y is equal to c1 x1 plus c2 x2 plus c3 x3 up to cn xn, and this is the final equation for linearization. What we have to remember, we will be given small function. Here you can see y is a function of this, and we have to find out the partial derivative of that function with each the term multiplied by small x1 here, same way multiplied by small x2, like that we have to find out the value of small y. When we get the value of small y, we will get the value of y approximate. And that y approximate we have to find out. This will be more clear when we will get one small example. I will take small example. Here is the example in which what is given, function v is given pi r square h. It is r square h, equation of volume of a cylinder where r is the radius of the base and h is the altitude. Determine the equation for the variation in v in the volume due to variation r in the radius and variation h in the altitude. Means how that volume is changing when the radius and height of that cylinder is changing. So what you have to see here, the value of the equation is dependent on r and h, and this equation is non-linear equation because square is present. So we can write the function v is equal to function of r and h as pi is constant. Pi is constant, it is not a variable. So what we have to find out, the approximate value of v, which will be equal to vi plus small v. Where, from where this equation come? It is from this. Y is equal to yi plus y. Y is nothing but y approximate is equal to yi plus small y. So same equation we have to use in our derivation. So let's continue. So our function is v is equal to function of RH. So v approximate is equal to vi plus v. Small v we have to find out. So small v is nothing but from this equation, small v is equal to C1, x1 is here now r, and C2 multiplied by x2 is here nothing but small h. So here what we have to do, we have to compare v is equal to v into RH with y is equal to function of x1, x2. Here n is 2. So here x1 is r and x2 is h. So small x1 is small r, small x2 is small h. Then from this equation, what we want to find out, the values of C1 and C2. C1 will be equal to dou V by dou R at I. Why it is so? Because we have written C1 is nothing but dou Y by dou X1 at I. So Y here is V and X1 here is R. So it will be equal to dou by dou R of pi r square h. By taking the derivative, what we will get? 2 pi r h at I, which is nothing but 2 pi r I h I. Similarly, C2 is equal to dou V by dou H at I, which is equal to dou by dou H of pi r square h. Partial derivative with respect to h will be equal to pi r square at I, which is nothing but pi r square I. So what we will get? Small v now, putting the values of C1 and C2, 2 pi R1 RI HI multiplied by r plus pi ri square h. Then what will be the value of Vi? Vi is nothing but what is the value of V? Pi r square h. So what is the value of Vi? Pi ri square into hi. In the next step, what we have to do? Divide this, suppose equation 1. We have to divide equation 1 by Vi. So I will divide small v divided by Vi, which is equal to 2 pi ri hi into r divided by Vi plus pi r square into h divided by Vi. Let's put the value of Vi on the right side. 2 pi ri hi divided by, multiplied by r divided by pi ri square hi plus pi ri square into h divided by pi ri square hi. What I did here, I just put the value of Vi in the denominator. Then here what we did, divide equation 1 by Vi. Then what we are doing now, by cancelling the common terms, what we will do, this will get cancelled, this ri will get cancelled with square, hi will get cancelled with hi, this square will get cancelled with this square, pi will get cancelled with this pi. So what we will get, final answer, V upon Vi is equal to 2r upon ri plus h upon hi. In simple form, small v is equal to 2r upon ri plus h upon hi multiplied by Vi. And this is answer. What they have asked, determine the equation for variation V in the volume due to variation of R in the radius and variation of H. So this is the equation which they have asked. This part which we have seen in the today's lecture. Hope you have understood this concept. Let's take a review what we have seen today. First we saw what is meant by linear equation, what is meant by non-linear equation. The solving of non-linear equation is difficult, so we want to convert that non-linear equation into linear equation by making the approximation. During the approximation, there is always creation of error, and our aim is to minimize that error, so the answer actual which we are getting is near to the real answer. For that, we saw one example where a non-linear relationship between y is equal to x square we have found by considering all the concepts, and we got this relationship. Then using the same relationship we solved one problem where we found approximate value is coming near to the actual value of y. We saw the general form of equation, and by using that general form we solved one problem. With this we will stop for this lecture. In the next lecture we will solve some more problems which will clear your concept. Thank you.